Hello and welcome to Beginners Python and Machine Learning. My name is Tim Cummings. Tonight we're going to be looking at how to use Python with Docker. And Docker is a very popular container technology, and it allows us to really segregate our work and also does a lot of for us in dependency management. So these sessions, we hold them in person and online. Tonight we'll be in person in Brisbane City at the Visitor Information Centre, above the Visitor Information Centre in Queen Street Mall. But if you can't make it, then this is a quick session online just beforehand. But we'll be going for an hour and a half after this session, so you can keep asking questions in Slack if you're still working through the code after the session has finished. So this is the Slack that we'll be on. We'll be in the Learning to Code channel on Beginners Python. And you can also ask questions in the YouTube chat. So, but some of them get censored, so I don't always see ones that you type into that. All right, now you don't need much tonight. You just need Docker installed on your computer. So actually we'll go to the instructions, which I have put here on GitHub. So if you click on this link in the Meetup, and the link is also below the video in YouTube if you're looking there, it will open it up in GitHub there in our session summaries, Meetup 169, which is tonight's session. So yes, to follow this tutorial you need to install Docker. So I'd get started there if you haven't installed it already, because it will take a little bit of time. The Docker engine is free. Docker Desktop, which we'll use a little bit tonight, is free except if you're using it for commercial use in a company with 250 employees, more than $10 million annual revenue. But just for educational purposes, that's free as well, and small companies it's free as well, or you can just decide to just use Docker engine from the command line, which is mostly what I'll do tonight. When you install it on Windows, it needed to install on my computer Windows subsystem for Linux 2 as well. But it was pretty much automatic as part of the install procedure. We'll go through, so for references here, the Docker site itself has got a getting started, and some of the things that we're going to do tonight will come from that getting started. But we're also looking at it from a Python perspective. And so here's some other links that give you some information on how to use it with Python. And this is an old link here, and it's old, but it explains why to use containers rather than virtual machines. So Docker creates lightweight portable containers, and they're very similar to virtual machines. If you know software like Parallels or VirtualBox, that's Virtual PC. They're software that lets you run another operating system on top of your own operating system, and they do that by virtualizing all the hardware and just creating a totally sandboxed area for you to run that run your code, and it's totally protected from everything else. But it's quite memory intensive, and it takes quite a lot to set up. So Docker have got around that. It's very lightweight, doesn't use much in the way of resources. So we get a lot of the benefits of using virtual machines with much faster to set up and much less resource hungry. So let's get started and see how we go. Now I've got a command, I've got a Windows terminal running here, so you could use command prompt or Windows PowerShell. I'm running PowerShell in Windows Terminal, and we'll just try running this first command, docker run hello world. And that will tell us whether we've got Docker installed properly on this computer. So it says unable to find the image hello world latest locally. So it actually goes off to the internet, so you'll need an internet connection, and grabs the latest image for hello world, and it runs the code. And all the code does really is just print a message to the terminal and then finishes and leaves us in the command prompt here, or PowerShell in this case. Now, I've got Docker Desktop running, so we'll see what's happened since I've run this command. What it did, if you look in images here, you'll see it's created this. It's pulled this image called "Hello World." It's pulled that off the internet, and it says it's in use. It's being used by one of the containers. And if I look in containers, there's the one that it's created. It's based on this image, "Hello World Latest." It gave it a random name. They've called it Blissful Swirlies or something. On your computer, it'll have a different name. And it's saying the status is exited. So it's all finished. I can just delete that. Now that it's finished, delete it forever. And deleting containers is pretty common. In fact, it's so common, people will often, when they create a container, they'll put in the command that says, when this finishes, just delete it automatically. Your images, on the other hand, you might want to keep them around, or if you're getting it from the internet, it doesn't matter anyway, you can delete that one as well. All right, so we'll go over this a few times tonight, what the difference between images and containers are. But let's get started and try to create some, and then maybe you'll start to understand what's actually happening. And remember, if you've got any questions, just ask on that Slack channel or in YouTube chat. Okay, so let's create a folder to put all our stuff in. So I'm just in my Windows home directory here, so I'm going to create a folder that I'm going to call BPAML, so Beginners Python and Machine Learning Session 169, where we're working with Docker. So I'll just create that folder. I'll change directory into that folder. And then for our first task tonight, we're going to do a task called Hi from Pi. So let's create another folder there. And we'll call it task Hi from Pi. Now, all you really need for tonight's exercises is just a command line and a text editor. So you could use Notepad, Notepad++. I'm going to use Visual Studio Code, but I'm not going to use any of the features of Visual Studio Code apart from its terminal and its text editors and an easy way to see the files. So I'm going to start code from this folder, code dot, the dot being this folder, and code being the code for Visual Studio Code. And here we are, we're running Visual Studio Code. We're in our folder called BPAML 169-Docker, and we can see our first folder that we've created, task Hi from Pi, and I spelt it wrongly. So let's create another folder called task Hi from Pi. There we go. What if I can delete this folder? Delete. Yep. All right, now in this folder, we're going to create a file called hi_from.py. So I'll select the folder, I'll click on the little plus document. You can see here on the list, if you haven't used Visual Studio Code before, I'm in the file area. These two documents here says I'm in the file area. I can also be in other areas like source control or searching, but I'm going to do everything from the file area today. Let's create a file, and we'll call it hi from, and this time you should use an underscore, from, and then .py to say it's a Python script. So we're just going to write a very simple Python program. See, I haven't even installed the extensions for Python into my Visual Studio Code. So you're welcome to do that. I'm not going to do it just because I'm not using any of them tonight. So let's copy this here and paste. So here's my very simple program. It's just a 2-line program. Imports the sys library and tells me what version of Python I'm running. I can see the dot up here says I haven't saved it yet, so I'll do Control S to save. And now it's saved. Now I want to try running this from my from terminal, and I'll pull up the terminal inside Visual Studio Code, which is just Control backtick being the key on the top left corner of your keyboard. It's brought up a terminal. It's also PowerShell. Let's try running this code. So let's first of all just see if we can run Python. So if I try py on Windows and tell me what version is running, it says I'm running Python 3.10.9. Now when I installed this Python, I didn't add Python to the path, so py works, but python doesn't work. So I'll get an error that it can't be found. But that's all right. I know that I've installed Python 3.10.9, and if I want to run my particular code, which is in that folder, task hi from .py, it just prints up hi from Python 3.10.9, and it tells me what version of Python is currently running. All right, so that's just a bit of background information. That's how you'd normally run Python if you weren't using Docker. So let's look at how we can run this using Docker. So the next step here is create a Docker file in the same directory. And the name of the file is really important. So it's got to be Docker file with only the D is capital, the F is lowercase, all the letters are lowercase except for that D. Let's go back into here, create a new file, and we'll call it Docker file. I mean, the case sensitivity is probably not so important on Windows or Mac. You can see it's got extensions for Docker, but I'm not going to install them either. But on Linux, you definitely have to get the case exactly right. So let's copy this contents into the file and have a look at what we're doing. So what we're saying is we want to create a Docker image. So remember the difference between images and containers. So the image is what so we're going to base our container on a previous container. The only one you've seen so far is the Hello World one, but there's also one from the Python people. And so it's just called Python. And then we do a colon and say which Python do we want? And we say, well, let's use 3.11. So that'll be using version 3.11 of Python. And remember, we've only got 3.10 Python installed on this computer. Now this image, remember, it's a virtual machine. It's like a virtual machine. It's just going to be running in a container. So it's going to have a directory, and we'll make this directory we'll just call it bpaml169. It'll only be in the container. It's not going to be on our computer. And then we want to copy everything that's in our current directory, which is just this one file, task hi from py, into this working directory. And then we've got an entry point, and that basically says what I want my Docker container to do when it starts running. So it'll start running, it'll fire up an operating system inside it, and then it'll run Python hi from .py, just like I ran here, Python hi from .py on my computer, but this is going to do it in the container. All right, so I'll save that Docker file. And now that I've created a Docker file, I've been through what these do. We're going to build and run the file. So, and we're going to build the image that's going to use the Docker file. And we're going to give it a name. The tag, we're going to call it bpaml169 hi from py image, just to enforce that it's the image. And then we're going to run it, a container based on that image. So just to save on typing, I might just copy this and paste it into here, paste, just by right-clicking. And now what it's doing is it's downloading the Python image for 3.11, and then it's going to run our build commands. It's going to create a directory. It's going to copy our file into the directory, and it's going to say configure it so that that's what will run when it runs. And that's everything that happened in the build command. And that's all of this stuff here. It might take a bit longer on your computer because it has to download a bit more from the internet, because it's probably cached some stuff that I've downloaded previously. And then I run the docker run command, and that runs the image. And here's the output from the image. It says hi from Python 3.11.1, and tells me which version of Python has been running. So even though I don't even have Python 3.11 installed on my computer, I can run these Python 3.11 program here, and then change directory back up to where I started. Okay, we can have a quick look at here. We can see it's created this image. The image is in use by a container. The container they've called Musing Lumiere, and it's run and finished. So that's what we've done. Okay, here's some other Docker commands, but I won't go into them now. They'll just be a bit confusing at this stage. And we'll go on to our next task. So our next task is going to be, how can we run a web application that's hosted on one of these containers, a Linux operating system in one of these containers. So we'll go back to our file and we'll create a new folder. And I'll create the folder in the right place. It's going in the wrong spot. Let's just create it down here. So we'll create the folder, and it's called Task Flask. And in this folder, we'll create a file, which will be a Docker file. And in that Docker file, we'll put this code. Okay, and save that. So once again, we're going to build an image. It's going to be based on Python 3.11. It's going to have the same named working directory, but when we're building it, it's going to actually use Git. So Git is installed in this container image, and it'll clone from my GitHub repository a web application that's based in Flask and shows all the Australian Prime Ministers. Then I'm going to, once I've cloned that, I'm going to change the working directory into that directory. And I've done a relative directory, but I won't go into that now. I'm going to install pip, and then I'm going to install all the requirements of that application. I'm going to initialize the database, and then I'm going to run. So all of these things happen while we're building the image. This last one, that runs when the container is run. And that's why it's a command rather than a run. Okay, so let's try building this. And so I'll change directory into Task Flask. We'll build it with a tag name so we can keep track of our images. And we'll build everything that's in the current directory. So we'll use the Docker file that's in the current directory. And I've typed something wrong there. Docker build. So one of the things about these containers is it's based on layers. So you take an existing layer and just add the things on top of that you want to make specific to your image, and that speeds things up quite a lot. So we've done that to the Python 3.11 image, and we've just added in our Prime Minister application. Now we want to run it. So docker run, and then you see here I've put in the command --rm, which is basically saying when you're finished, delete the container, because I don't want to save it. I'll save the image for now, but I won't save the container. And then ports. So if you remember from our Flask applications, they ran on port 5000, but 5000 is actually in the Docker network. So we need to somehow talk to that, and we're going to, by passing in port 4000 here to port 5000, and I just made them different. They could be the same, but I made them different so we can see which one's which. 5000 is what's running on the container, 4000 is what's running on our computer, and we're just basically doing a port forward from one to the other. What have I typed wrongly here? Oh, yep. I didn't choose 169 in the name. Okay, so that's taken our image that we've built and it started running it in a container. It's giving us this typical warning from Flask saying we're just using the development server, but that'll do for now. And here's a link on our own computer. So we'll open that in a new tab. And hopefully you should see our Prime Minister's application and all the Prime Ministers of Australia. So we can view information about the Prime Minister, when he was Deputy, when he's Prime Minister, and which party he's from. Okay, so I'm looking for comments, see if anyone else got the Prime Minister app to run. That'll be good to hear if you did. But we want to use a proper production server here rather than this development server. So how are we going to do that? So first of all, we need to quit this application. And it's saying use Control-C. I find that doesn't, Control-C in Windows doesn't work too well. It should work on other operating systems. But we can stop it just in here. Here's the name, BPAML Flask. It's running. And let's just stop it. You'll notice when I stop it, it automatically deletes itself because we use that --rm flag. And automatically deleting is a good habit to get into because it reminds you that you should never save data into your container. If you want to save data that's persisting from when the container finishes, you should store them in volumes, but that's we won't go into volumes tonight. All right, and you can see it stopped here, so that's all fine. So let's create a new one, task GUnicorn, and this is going to use a proper deployment server. Okay, so cd ... And unfortunately I've renamed it wrongly, but that's okay. So in GUnicorn, we'll create our Docker file. And it's going to be based on the image that we've already created. So it doesn't need much more to set it up. And I'll just rename it here. If you've been following the code properly, you won't need to rename it. Okay, and now let's build and run this this image and container. So it's building the image, and now it's running the container. And if you remember GUnicorn, or you might not remember, GUnicorn runs on port 8000. So this time we're not interested in port forwarding 5000, we're port port forwarding 8,000 to our local 7,000. So you can see it's listening here, and we have to put in this information about 0.0.0. Otherwise, Gunicorn will only list on localhost 127.0.0.1. So let's see if that's working. So yep, you can see we've got our web application is running. Let's have a look at our other one, which is from our container that's no longer running. I'll click on that and it won't find anything because there's nothing on port 4000. Okay. So now we've got Gunicorn running, but in a typical deployment, you'd run this all behind a proper web server like Nginx or Apache, because they can be serving up static content like images, JavaScript client files. It'll take care of virtual hosting, all your security certificates. So you want it behind a proper web server. So how are we going to do that? And what we're going to do is we're going to create a Docker container that's just a web server. So with the containers, you try to just do one task and do it well. So this one, here's a configuration we're going to have for our Nginx web server. And we'll create a Docker file that uses that and creates a Nginx container. So let's create, it just puts to the wrong spot, doesn't it? Oh, I better stop this one. So another way to stop I'm running out of time, so we'll just stop it from here. Okay. We'll create a Docker file in there. And all it really is that someone's built an Nginx web server in a Docker container. And we're just going to add our config file on top of that. So I'm going to create the config file as well. So I'll save that. Now, because we're going to have two containers running, we need to create a network between the two containers. So we'll just do this using the Docker network command, which we can just type on the command line. So I've just called it network for BPAML 169. And it already exists because I created it in my testing before, but you wouldn't get that error message. And now let's go into this directory. We'll build our Nginx server. Based on the Docker file in this current directory. Learn how to read instructions. Docker build. So that'll pull that server down from the Docker hub. And we'll build it, and then we'll run our Unicorn container and tell it what network to use, and we'll run our Nginx server and tell it what network to use, and then just check that they can talk to each other. So that's now running the unicorn container. Now we'll run our that's running unicorn. Now we'll run our Nginx. And now let's see if they're running. So if I look in Docker Desktop, I've got 2 running at the same time, Nginx and gunicorn. Let's just see if we have successfully, and I'm using port 8888 for my web server. And there we have success. That's all running. It's the same success in each case, but this is a much more robust deployment. This is a full deployment that you would do if you're wanting to deploy this web application. And we've done it just by creating a few Docker containers. Okay. Now we can stop the containers. So if I run Docker PS, it'll show me which ones are currently running. Just make this a bit smaller. So you can see these are the containers that are running, and I can just use these container IDs to stop them, or I could use the names that we created. Here are the names: con Nginx and con container gunicorn. So if I say docker stop con Nginx, that one stops, and then I can stop gunicorn. Okay, let's have a look at our Docker. They've deleted themselves. The images are still there. These are the images that we've created tonight. So we can always start up new containers from these images if we ever want to. All right, well, I hope that's been useful. I'm now going to go on to the in-person session. If you're having a go through these exercises, please ask more questions in the Slack chat. You won't be able to do the YouTube chat because it's that finishes when the stream finishes. Well, thanks very much.